Thank you. Okay, so science is trying to explain the world, and it is looking for the best evidence available. And the worst would be like anecdotes. A bit higher up would be cross-sectional studies, experiments, and on the very top there are the meta-analyses. Meta-analysis is basically the summary of the results of several studies. And the way you would do this is to search for literature in your topic, then you screen the articles, extract the data from the articles, that would be done by humans, and you aggregate the findings. So it is a bit cumbersome because there is a lot of human work involved, especially because you have to make all decisions like in the screening and the data extraction by humans, and at least by 2 humans. And this means that you need not just domain-specific knowledge and methodological knowledge, but you also need to be good at teamwork and data management and organization and file management. And that's the last 2 things that I'm going to focus on. So it would be really cool to do this whole thing in R, right? So it would be really great to make this whole process completely reproducible and make it possible to combine human and machine-generated files into one single meta-analysis. So it would be great to get the articles into R, generate all the files that are needed for the manual coding, then harvest all the data back together, compare them, validate them, and then being able to do the actual meta-analysis. And it would be really great to do this in a reproducible way using the tidyverse principles. So there is the metamanager package that I'm currently developing, and it is basically using these principles. So it uses Google Drive for human encoding, and with these simple words you can create a drive structure, set up a team of researchers that you can use, and also there are wrappers to do this in one single step. So you would be able to very easily to create several files reproducibly and distribute it to several coders, and then add the columns that are for human encoding, and then save them locally. And then you can just upload it to Google Drive, or later when you want to harvest the results, you can download them, and this is for several files. So you are basically getting all the data from one Google Drive folder, and you are able to combine them into just one data frame with this single verb. So why Google Drive? Because not everyone who will you work with can code. So it is great that Google Drive provides a GUI for manual data entry, and it also has built-in version control, and it is very user-friendly, basically. But you could use GitHub and Dropbox. So it is possible to monitor and validate the manual work by using this verb. So you can see that all the pairwise comparisons are made between the separate coders. So these are the metrics. And you are able to correct human errors very easily, like correcting small errors in predefined words, and also to check for conversion errors when you want to aggregate all the files together. Okay, so this would be like a use case of creating the data extraction. Of course, everything could be done in R very easily, but these are like making the whole process even easier to follow. So you would get all the screening from Google Drive, then you assign all the articles again for the extraction, and you add the columns, and you save it locally and upload it to Google Drive again. Okay, so future plans include functions to augment the screening process with a machine learning approach. So with a training set, people would be able to do the screening faster. It would be great to combine all the literature search functions that are currently not integral part of this to be like in a separate package, and also to be great to create ggplot2 based graphics because the current meta-analysis stuff are doing Bazar graphics. So if you're interested, you can get this package, the metamanager package, on GitHub, and you can find me on Twitter. And I'm very happy for any feedback, even here or on GitHub. Thank you.
Thank you, Tamás.